Surface coatings. This subject deals with protecting surface of any material from the effects of environment. This subject, surface coating, has got the importance not only for protecting the surface but also to add aesthetics to overall appearance of a substance. Preparation and application of coating is an important industrial activity in modern world. You can see exterior and interior of any building, vehicle, substances of daily use are coated. In this lecture, we will be learning about the unit of surface coatings. In this lecture, we will be learning about its historical background, importance, types of the surfaces which are coated, objectives of the surface coatings, and various types of coatings which can be classified as conversion coatings, thermal coatings, metal coatings, deposition coatings, and organic coatings. In this particular episode, we will be discussing till metal coatings, its important characteristics. Use of surface coating or paints dates back to prehistoric period. It was around 25,000 years ago when primitive human used salts of iron, manganese, burnt wood, chalk mixed with animal fat for expressing their art on the walls of caves. In Spain, France and Africa, many such paintings have been found where they have decorated walls of the caves by the drawing of animals they were hunting. Here we can see the variety of colors, brown, red, yellow and so many shades they have used for decorating the walls of the caves. Later, Egyptians improved the binding capacity of coatings through gum, wax and many pigments from organic origins were also used. It was around 600 BC to 400 AD when Greek and Roman further appreciated use of coating for preserving as well as decorative purpose, and use of drying oil in varnishes was introduced. In Europe, it was around 13th century when use of varnish for protection of wood and furniture items was started. Industrial Revolution in 18th century made a lot of progress, as now most of engineering applications demanded protection from the environment due to problem of corrosion. Now we can identify the basic objectives of coating any surfaces. First of all, primary aim is to provide protection from the environment and thus corrosion resistance. Adhesion or binding. For any coating, it should be properly bound on the surface. It should be opaque. It should provide color, smoothness and gloss to the surface to become attractive. Specific mechanical and physical properties such as wear resistance, electrical properties, thermal insulation and oxidation resistance. These are also very important characteristics which should be present in the coating. Now, factors which affect selection of any coating are type of the substrate, like If our substrate is metallic, then selection will be different, and if our substrate is made up of wood, plastic, then it will be different. Next is the objective of coating. We want to coat a surface just for the purpose of protection or for the decoration, or it may be for both. Durability. And finally, it is the process of surface coating which is very important factor. Types of the surfaces. We can broadly divide various type of surfaces into two categories: metallic and non-metallic surfaces. In the non-metallic surfaces, constructional and many other material, plastic, wood and many items of daily use are covered. Surface coatings can be classified into many categories. These are the some of the important categories. Conversion coatings. This again can be divided into phosphate coating, oxidation coating, chrome coating and anodizing. Next is thermal coating. Thermal coating, it can be divided into diffusion, carburizing, flame spraying, etc. Next is the metal coatings. Metal coatings, it may be by electroplating method or by electroless plating method, where electrical energy is not required. Deposition coating, it can be divided into physical vapor deposition and chemical vapor deposition. And finally, very important category, organic coatings such as paint, enamel and many more types of paints. Now coming to the first category, that is conversion coatings. These are basically inorganic surface barriers produced by chemical or electrochemical reactions brought at the surface of base metal. These serve as excellent base for paint, lacquers and oils. Chemical reaction of base metal with phosphate of iron, manganese or zinc with phosphoric acid causes growth of a crystalline layer on the surface of base metal. Now depending upon the type of the phosphate selected, iron, zinc or manganese phosphate layer is formed. This type of coating is typically applied to carbon steel, low alloy steel and cast irons. It is sometimes also applied for the protection of cadmium, aluminium or tin. In the phosphate coating, the layer we get is typically very thin. It is 2.5 millimeter and usually grey in color. This type of coating is used as a primer coat for paints. This can be applied by either immersion method or by spraying or brushing. Next category of the conversion coating is oxidation coating. Here, treatment of base metal with alkaline oxidizing solution or gas is done. Here, we get increased thickness in comparison of phosphate coating. This coating is corrosion resistant, hence protective. This serves as a good base for paint, oil, but it has got less absorptive power than phosphate coating. Oxide coatings on steel with variety of color ranging from straw, yellow to blue are obtained. Next is the chrome coating. immersion in a chromic acid bath with other chemicals to coat surface is done. This coating is done in the strongly acidic conditions, that is in the pH range of 1.8. Then surface film consisting of mixture of chromium in the oxidation state of 3rd and oxidation state of 6 is obtained. As we know, chromium in the oxidation state of 6 is known to be carcinogenic. So, nowadays alternatives are being found out, and molybdate chemicals currently are treated as best substitute for coating of aluminium. Chrome coating is very good to minimize atmospheric corrosion. So, it is used for protection of zinc, aluminium, magnesium and many more alloys. This is applied to everyday items such as hardwares and tools which are exposed to the environment, and this can usually be recognized by their distinctly iridescent greenish yellow color. Here you can see these are tools which are coated by the chrome coating. Next category under the heading of conversion coatings is anodized coatings. Here surface of non-ferrous metals like aluminium, zinc, magnesium and their alloys are coated. In this method, anodic oxidation process on a base metal is followed and base metal is treated as anode. Base metal is suspended in sulfuric, phosphoric, oxalic or chromic acid bath, and we get thicker than natural oxide film, hence shows improved resistance to corrosion and mechanical injury. Next category after conversion coatings is thermal coatings. In the thermal coatings, again it may be of 4 types: surface heat treatment, diffusion coatings, hot dip coatings and metal spraying. First of all, surface heat treatment. As the name suggests, in this method basic concept is to heat the surface of the substance to the austenitic range. Then it is quenched to form martensite surface. Here steel is taken as an example. Various type of heating methods can be used. One is flame treatment and other is induction heating. Next, under the heading of thermal coating is diffusion coating. In this method, with low carbon steel substrate, the surface can be enriched by diffusion of carbon or nitrogen. Now, diffusion of carbon, carburizing. In this method, steel is heated to austenitic range, which is from 850 to 950 degrees Celsius in a carbon rich environment. Then it is quenched and tempered. In the nitriding method, nitrogen is diffused into steel and it occurs around temperature range from 500 to 560 degrees Celsius, and a very hard thin surface is formed. This type of coating is good for chromium, vanadium, tungsten and molybdenum steels. Next is metal diffusion. Here metals such as chromium or aluminium, they are diffused into the surface to form corrosion resistant layer. In case of aluminium, it is used to increase the high temperature corrosion resistance of steels and superalloys. Next type of thermal coating is by hot dip method. These coatings are also used for corrosion protection. First of all, galvanizing. Parts of the substrate are dipped into a molten zinc bath. A layer of zinc carbonate will be formed, and this type of coating is used for protecting steel. Galvanic annealing. Galvanized parts are then heat treated to 500 degrees Celsius around, so that a iron zinc intermetallic state is formed. This is used for metals that need spot welded to protect copper electrode from alloying with zinc and reducing its life. Next type is aluminium coating by hot dip method. Here it is alloyed with silicon. Coating is used on steel for high temperature applications that need a lustrous appearance. Automobile exhaust is an important example in this category. Next type of thermal coating is by metal spraying method. This is typically used to improve wear resistance by creating a hard surface over a tough bulk body. In this process, molten particles are deposited. A stream of molten metal particles from spray gun are deposited on the surface of substrate. We can deposit the stream of particle by two methods: wire gun and powder method. In the wire gun method, metal wire melted in oxyacetylene flame, and then it is atomized by a blast of compressed air. This method is widely used for common metals. Another method, powder metal method. Here finely divided powdered metal is heated, then passed through the flame of blowpipe. It results into the clouds of molten globules, which are then adsorbed on base metal surface. This method is used for low melting metals like zinc, lead and tin. In the metal spraying method, first of all, surface undergoes a bonding process with the molten particles, and we get a continuous but porous coating. Since coating is porous, so we need to seal the surface, and hence sealer oil or paint is applied to provide smoothness. This gives greater speed of working. This process is very easy for application. Adhesion strength is less than hot dipping method or electroplating method. Next category is the metal coatings. In the metal coatings, we can further divide into electroplating, electroless coating where electrical energy is not required, and metallizing of plastics and ceramics. First of all, electroplating. Objectives of the electroplatings of the metals. This is used to increase wear and corrosion resistance of the metal. As we know, surface of the metals gets corroded very easily. So, this method is very useful to provide corrosion resistance and to improve its physical appearance and to impart hardness. This is also used for increasing its commercial value. Now, if we are performing the electroplating method on the surface of non-metals, then again objectives are quite similar, as to increase strength of the non-metal, to preserve objects like plastics, wood, glass, etc. from the effects of environment, and very important point that this method is used to make surface of lightweight material conductive. As we know, non-metals are bad conductor of electricity. So, for this purpose we can coat their surface by the electroplating method, thus we can make them conductor. Main features of the electroplating method. Electrochemical process is used to create a thin coating bonding to the surface of the substrate. In this method, quite uniform film with very little pinholes per unit area is obtained. Process is slow. Therefore, coating thickness can be closely controlled and it can be in the range of from 10 micrometer to 500 micrometer. So, we can see how thin film can be obtained from this method. Applications of the electroplating method. Here are some of the important applications. Tin and zinc are deposited on the surface of steel for further working. Zinc and cadmium are deposited on parts for corrosion resistance. Cadmium is toxic and therefore it cannot be coated for the purpose of appliances which are used in the food applications. Copper is deposited for electrical contacts. Nickel for corrosion resistance. Chromium can be used to impart wear resistance to dies and reduce adhesion to workpieces such as aluminium or zinc. Precious metals can be electroplated for decorative value and for electronic devices. Some of the important characteristics and factors which are to be paid attention in case of electroplating are thickness of the coating, its adherence, it should be properly bound with the substrate, hardness, it should make the surface hard, so it will become tough, it should look bright, it should provide gloss, protective value, decorative value, and throwing power. Throwing power means ability to give uniform thickness. Electroplating is done in the temperature range from 35 to 60 degrees Celsius. So, we can see it is near room temperature or slightly warm conditions in which good electroplating is obtained. Cleaning of substrate, this is very important. If surface is not properly cleaned, then coating will not be proper. Composition of electrolyte bath. Many conditions, types of the salts we are choosing, their concentration we are taking, they affect the electroplating. Current density. As we know, low current density provide better diffusion and we get uniform layer. pH of the bath. It should not be too high or very low. As we know, At lower pH means acidic conditions, burnt deposit is obtained, and at a higher pH hydroxide ions gets deposited on the surface. Now at the end we will revise once again whatever we have learnt in this lecture. First of all, we have gone through the historical background of the surface coating. It's starting since prehistoric period, types of the surfaces which can be coated, objectives of the surface coating. It can be for protective purpose and it can be for decorative or for both purposes. And then we learnt the classification, conversion, thermal, metal coatings, deposition and organic coating. And in this particular lecture we have done till metal coatings. Various conditions, experimental details of the metal coatings, especially the electroplating, we will learn in the next lecture. Thank you.